Bonnie, Ryan and I are talking about digital supply chains in the built environment. Now, Bonnie's with GS1, and we'll learn about them as we're talking. My name's David Mitchell. I'm the chairperson of Building Smart Australasia. Now, this is the second episode in a series of podcasts about digital supply chains in the built environment. Previously, I spoke with Mark Fairburn with MasterSpec in New Zealand, and we talked about this problem that in the construction sector or on our projects that often the design intent is unclear. So we came up with, collectively we've come up with a solution, but step one of that with Mark was about digitally embedding product specifications, because the concept here is that if we have a specification that is digital, then it's far easier to transfer it down the supply chain. And that would what that is a key enabler for is to allow us to measure the construction gap. So if we create an equation, the construction gap equation, where we can measure the difference between what was intended to be built versus what has actually been built. And that would be something that was good for industry. So today, what we'll be covering is GS1 itself, and in particular, its GDS, its Global Data Standards, and what GS1 does, and also how the GDS operates. And we'll look deeper into this problem of unclear design, but more importantly, how it manifests in the supply chain, because that's what Bonnie specialises in, is supply chains, and we'll turn our minds to what we think the best solution is. In terms of what's in it for you guys, you're going to learn about how to uniquely specify products. You'll also learn about how to combat substitution, whether that's something that you want to occur, so like authorised substitution, or whether it's something that you want to avoid because it's not approved. You'll also learn how to enable traceability, and how, most importantly for our product suppliers and manufacturers, is how to create new opportunities for their businesses. So first of all, let's turn our minds, Bonnie, to what GS1 is, and in particular the GDS and how that might operate.
Yeah, sure. So thank you, David. Great to be here. So I guess the first point I'd like to make is that for those that may not know GS1 at all, that we're a not-for-profit member-based global data standards organisation. So we're probably best known for introducing barcoding to industry back in the mid-1970s, and really today as consumers we can't go into a major retailer anywhere in the world and not actually be faced with the GS1 standards. And you may not know that you are, but every time you scan a product at the retail point of sale, that is in fact the GS1 data standards, kicking off the supply chain for the product that you've just bought. So, barcoding, and we're often referred to as the barcode people, and that's because we introduced barcoding.
And that's what I thought you were when I first met.
Well, barcoding is still a very relevant and prevalent technology that's in use in many supply chains around the world today. And predominantly the barcode itself is really used to connect the physical object upon which the barcode is represented to the information and the data about that product. And that is the piece that's really more, increasingly more important as consumers and end users and supply chain participants are increasingly wanting more and more information about the products that they're buying or handling or installing or whatever. So the barcode is really a mechanism to, in effect, capture and kind of make that data accessible to whoever needs to know. But I guess from a in the context of the conversation we're having today in the building and construction industry, and really being able to add value and enhance the specification process. And as you said before, being able to provide specifications in a digital way, but then you really need to, have a lot more detail about what those specifications are. And so we start to delve into, what are all the products that make up the built environment effectively. So, and that's where the GS1 standards start to really play a role.
Yeah, and that's where, like in that construction gap equation, where we've looked at uniquely identifying specified products by using the GS1 standards, and the reference is to a G10. And then in my simple mind originally, I thought, well, we could just scan a box that comes to site, and if the G10 matches, well, we've got the right kit. But that's not quite true, is it? And
No.
You've put together a bit of a graphic to help us understand this.
Yeah, so the foundations of the GS1 standards is really the sophistication of unique and unambiguous identification, because you really need to have certainty about what something is. And so anybody can apply a digital identifier to a product, but unless you're speaking the same language as the next person, it becomes ambiguous. And when you have ambiguity in the supply chain, you most certainly end up with errors or misunderstanding about what the information is. So identification is a foundational piece, so that we can in fact get to a point where we have certainty about the products that we're specifying, that we're procuring, that we're receiving and indeed installing, and then be able to effectively provide a reconciliation, as you say, between what was specified and what actually occurred.
Sure. And like thinking about the graphic or the infographic that you've put together to help us understand how that supply chain works. I mean, what are there's a bunch of critical building blocks that need to be in place for the information to get passed from one party to the next, so that ultimately we can read it at site, isn't there? Yeah,
so products and materials pass through the supply chain from point of, raw materials all the way through to installation. And you want to be able to have a way of identifying those as they're travelling through the value chain, and also sharing data about those as they're travelling through the value chain. So we have frameworks, data frameworks that, recipe books, if you like, in terms of how to identify materials, how to identify locations and assets and all of the physical things that make up a supply chain or a value chain. So if you've got a material that's being produced in a factory, you want to be able to identify and then identify it properly digitally, and then pass that information to the next actor in the supply chain so that they can make use of the data that's been generated at source. And, and that kind of principle applies at every step in the chain, if you like.
Sure. So one of those critical building blocks is the identification, but it must be marking as well.
Yes.
Is that the case?
Well, of course. So this is where the barcoding comes in, and it could be barcoding or it could be RFID tagging, or, moving forward, it could be IoT devices or some sort of data capture mechanism where you can physically mark an object, embed the identification into it, and then as that object moves along the supply chain, actors can, read those barcodes or those tags and extract the relevant data about that object at that particular at that particular process. And then, of course, the third pillar of this is being able to exchange or share that information with relevant party and make use of that information in the relevant systems that exist in the supply chain, whether they are asset management systems or purchasing systems or logistical systems. You have to make use of the data to drive the process. But you have to have
And the G10's the connector for that, right? So it's the thing that you're reading on the barcode that is then opening up a database depending on who's allowed to see what.
Yeah, exactly. And so the design of the system, obviously, it's probably not enough time to kind of to really delve into it too much today, but the global trade item number, or the GTIN as you call it, is the unique identifier for all products. So we need this common language so that at source, whoever the product manufacturer is, the product identifier effectively becomes part of the intellectual property of that product. It effectively gives it its own globally unique, passport number, if you like, or a fingerprint. And then when you add data to that product then has its own unique identity that cannot be misconstrued, if you like. And so you start to get consistency across the supply chain because everybody has the same understanding of what something is, and so you can start to trust in the data that's being shared about that product because the system is speaking the same language. So having this product identity to start with is absolutely foundational to everything, to building good traceability systems, to building trust in the process, to building effective product recalls solutions, and being able to share accurate, trusted data.
So if we can get that unique identifier passed along down the supply chain, then it could be a reality that we could have a specify a particular product and be able to measure at site that product has arrived. So if we now turn our minds to the problem, so Bonnie, you and I have both spent an amount of time with BPIC and all sorts of other organisations looking at this issue that has been certainly fleshed out by the Shergold Weir report. And a lot of that is to do with defects in construction, but substitution and these types of things are also a big component of it, aren't they?
Yeah, I mean, I guess it's okay to substitute as long as you can record, what's been substituted, and there's some sort of integrity check to say that that the substitution actually is still fit for purpose, or being able to easily uncover that there was a substitution that took place. So it's all about certainty. Yes. It's all about what did actually happen, and being able to capture and record and share information about what's actually occurring in the value chain, so that from an audit trail perspective, you can easily find something when something goes wrong. So often, in all sectors that we work with, I often hear it's all good when it's all good, but when something goes wrong, the forensic investigation to be able to go and find out, well, where did it go wrong? Who was responsible? Where did it occur? Where is it now? Those sort of questions become very difficult to answer if you don't have a connected supply chain, and you can only have a connected supply chain if you have systems that are connected, and they can only be connected if you're speaking the same language. You can certainly, otherwise you just can't. You can't do it. You're always going to have ambiguity and subjectivity in the context of the data. So and
that's what happened with the Lacrosse Fire, right, in Melbourne. It was an issue about substitution of a material. And so in terms of how these things manifest, I mean, they can manifest in really quite dangerous ways. And the market response to that is then to go out and try, or the government response is then to go out and physically eyeball all of the buildings in our capital cities to identify which ones have combustible panels and which ones don't. Whereas
correct.
the type of systems we're talking about, if there's traceability in place, we should be able to determine these things.
You would know that straight away. You would know straight away exactly what product is being installed, and that would that information would be accurate and trusted and passed over at the handover point. And so you'd have a complete digital record of exactly what went into the building. So you wouldn't need to go and do physical inspections because you would have that. You would have that certainty, but having that certainty requires a degree of trust and a high degree of collaboration in terms of what digital what digital processes and languages you're going to adopt.
And on the Lacrosse Fire, that was where, I mean, that it kind of reinforces our I suppose, description of the problem, because a lot of the court's time was spent around trying to work out what the design intent was. Even though it wasn't an illegal substitution of a product, it was done knowingly. It wasn't clear as to what the original product was going to be. And of course, then there's no benchmark to measure the alternative product against. So it all kind of seems like upside if we go down this pathway. But the other thing is, I suppose the other thing that Shergold Weir have identified is this reliance upon certifiers and them having to be like, I suppose, these superhumans and certifying that a building complies with all of the local authority requirements and that type of thing. And to do so, they rely on certificates from others. But I mean, presumably, if we're successful in implementing systems like this, the machine readability of it must have a lot of benefits, I would have thought.
Well, of course, because you are, if you can read a tag or a barcode, for example, on a product and extract information about it that's come directly from the product manufacturer, then you have trust in the process. You kind of. And I'm not a building specifier, so I can only imagine the challenges that they must face. But really, in many industries that don't have sophisticated supply chain, that comes down to the knowledge of the person at the time, and so you're relying very heavily on human capital and the experience of the person on the ground at the time, and you really want to get away from that and have trust in the process and trust in the data and making sure that you understand where the data comes from. So product manufacturers have a huge role to play. I mean, it's their product. There's a lot of information about their products, being able to deliver things like material fact sheets and technical installation instructions and, all the myriad of detail about those products, all of the master data that is associated and attributed to a particular product needs to be owned and managed by the product manufacturer, and then they need to have the control about who has access to their data, how they distribute their data, and making sure that that the data about their product is not manipulated by third parties along the way.
So thinking about our solution and the graphic that we've developed on that, so and essentially that relies on fleshing out the design intent. So we have at the center of design intent, we have a model, a 3D model, and linked to that model, we have an electronic specification, and part of that electronic specification is a GTIN that's referring to the particular items. Then to combat loss in translation or rumours in the supply chain as to what's acceptable and what isn't, we use IFC to be able to move that 3D information down the supply chain. On the capture side, what does that look like? So we need to be able to be reading this information in the actual sense. I mean, what kind of bridges do we need to build between the real world and the digital world for these types of things to work?
So for physical objects like products, you absolutely need to have a physical marking on the product. So and we're back to whether it's a barcode or an RFID tag or some sort of data capture device that
and for steel, that could be a laser tag.
It could be laser.
Like well.
It could be laser etched. There's all sorts of marking technologies that will allow a standard-based barcode or tag to be applied to a product. Right, so that everybody along the chain can read that tag and extract the same information, because otherwise you end up with everybody putting their own kind of label or their own marking on it, or it's only or a marking that's only relevant in a certain part of the supply chain. So you want that to be with the product so that it can be shared along the supply chain. So capturing that is really important because that provides the bridge between the physical object and the data or the information about that object. And so, we're back to product identity and effectively creating a fingerprint for that product so that it cannot be misconstrued along the supply chain. And it doesn't resolve the problem of if I choose to put a different product in, but if I choose to put a different product in than what was specified, you want to still be able to have certainty about what that different product was.
Yeah, and there's a record of those decisions.
And be able to record that. That's right, so that you that you can do that, so that there's that transparency in the value chain.
Yeah, and then thinking about the future, I mean, for say product manufacturers, say someone that's making, I don't know, room air conditioners, if they then know precisely where their air conditioners are, it must, provide opportunities for their business to expand into servicing or doing preemptive maintenance or replacement of those components, surely.
Yeah, well, look, in all industries really, manufacturers in the past have often, and still to some degree in many cases, don't have visibility of what happens to their product. So they sell their product to somebody and then, that somebody, does whatever they do with that product. It gets installed in a building or whatever. Yeah. The digitisation of supply chains everywhere is bringing manufacturers everywhere much closer to the point of use. Whether it's whether it's a soft drink manufacturer much closer to the consumer that's buying the Coke, or whether it's a cosmetic manufacturer, they're getting much better visibility of the supply chain and much better visibility of where their products are ending up. So they're building a much closer relationship with the person that's actually using their product. So for product manufacturers, of course, it's going to bring, it's going to open opportunities in terms of new business models, new channels to market, and extension of services, because they're going to be able to have a much closer relationship of the point of where their product is being used or consumed.
Yeah. Well, I mean, that's great, Bonnie. I feel like I've got a pretty good understanding of some of the technologies and the processes that are going to improve our, I suppose, business performance and certainly the industry. Now, it seems to me that digital data, it can make products stick. So if we're able to get this digital data embedded in the supply chain, there's every likelihood that that product is going to make it to the site. Now, next week, we're going to be talking, or in our next episode, we're going to be talking with David McNeil, and in particular, how he has implemented the GS1 GDS standards within their business, and how it has made, I suppose, how it has improved traceability and these types of things within the structural steel business. So I look forward to that discussion.